Now that I know that it's going to be recorded. No, so now I'm going to talk about a little bit on the Yasa regulations on PBN. You know that, well, I was involved in air navigation back in the day. I was a flight procedures designer, but that was almost 10 years ago, and luckily I have been able to almost forget everything about it, which is good news for my mental health. No, I was really passionate about that world, but everything has changed a lot in the last years. So I'll try to show you little highlights, some highlights about the situation, about the current regulation, and then we will try to trigger the discussion with the intervention of the other experts. So I'm going to try to share my screen. Let me see. Is it working now?
Yes, it's working fine.
Okay, fine. Very well, because I cannot see anything. So I'm going to give you an overview about the Yasa regulations on PBN. Unfortunately, our lead expert is not available today due to prior commitments, and I'll try to give you a glimpse about it, about a little bit about the PBN principles, affected rules, mainly aircrew and ops, PBN approvals, and other relevant provisions. We need to bear in mind that the PBN concept has evolved a lot during the years, and there was, at the beginning, there was a little bit of confusion with the different denominations, RNAV, RNP, and then ICAO decided to have a joint denomination of the principles and of the names. But still, there are a lot of different, and you can see a lot of different charts and procedures with different names, and sometimes it's not easy to distinguish them. But in any case, where this is not a PBN webinar itself, so let's try to talk about the general topics, and then if it's necessary, we'll discuss the details in the future. So a little overview. The PBN has already been implemented in some countries, and in some is about to be. This is evolving a lot. There are a lot of cost efficiency measures and advantages that should be taken into account. But there are also other challenges related to training, related to equipment, and this is something interesting to consider. And again, talking the same language when you talk about this type of procedures is also very, very relevant and crucial when you try to develop and to harmonize this type of procedures. So normally when you're trying to include or implement a new technology or a new development, you need to change a lot of things. And in this case, we need a specific airspace. And of course, we need to implement technology at certain airports. And this is also very common when we are talking about new regulations, new developments in aviation. Then you have a new set of regulations, a new set of technical documents, and then people need to understand what is going on. And some operators and some, I put here small operators, but it's not only the case for them. Sometimes it's very, very difficult for everybody, even for other aviation authorities, to understand the principles and to implement them. So that's another sensitive topic that it needs to be addressed when you want to introduce the PBN optimization or a PBN development in a region or in a country. So as I said, when we started flying, the way to navigate was to look out the window and to see what was down, and then you could orientate yourself and then the plane. And then, but from that moment to until now, everything has changed, and we used to fly from point to point. We needed ground-based aids, and we were only able to fly following the signals of the nav aids that were located, that were placed on Earth. But now we have different solutions, and the air navigation concept was the key to improve all the situation and all the air navigation world. And now we have specific points, and now we have a lot of flexibility to optimize all the flight procedures, all the routes, and to fly in a more convenient way. So again, navigation errors, the ground-based navigation systems like NDBs and VORs show that GNSS would be a solution. But also that was the case in general when you were talking about, let's say, higher altitude. To fly close to the ground, the precision that GNSS systems were giving us was not enough. But now the systems are performing better, and we are able to fly close to the ground with a lot better precisions, and we can manage to move aircrafts and to fly, allow them to fly together and closer. So as I said at the beginning, the different terminology was a little bit, it created a lot of confusion at the beginning. So ICAO agreed to convert to a single standard terminology. The term is PBN, but my experience tells me that this is mainly in theory, but because there are still a lot of charts, a lot of procedures, manuals, talking about different terminologies all around the world. And I think we still need to make an effort from all points of view from all stakeholders to finally harmonize all the terminology, because it still creates confusion. So the basic definition about PBN, it's area navigation based on performance requirements for aircraft operating along an ETS route, on an instrument approach procedure, or in a designated airspace. So that's the main idea. And the main idea behind PBN is that you need to have a monitoring and alerting system on board the airplane. That was the main difference between RNAV and RNP, and PBN has included that in the definition. So if we are talking about the evolution, and now if we are talking the recent PBN principles, and this is more related already to Yasa's regulations about PBN, now we are facing a full integration of PBN into the European regulatory framework, especially for pilot training and air operations. In the past, Yasa didn't have the competence to legislate about this, but the regulations in Europe have changed, and now EASA has the mandate to create regulations about this. So PBN now is being developed. The regulations are being developed by EASA. And now most PBN operations are treated as normal mode of navigation. In the past, this was the future, but now it is present, and this is the current, well, for some years, mode of navigation. So, and now talking about the requirements for specific approvals. In the past, there were a lot of, let's say, approvals needed for different procedures and different types of PBN procedures, but now that has changed, and now we are facing that what we need is an improved pilot training, testing, and checking rules, and also performance-based and proportionate operating rules. This change of concept and change of mind is going to be very interesting, and I think that when it's more consolidated, it will create a safer environment, even safer than in the past. There are still some requirements for specific approvals for complex PBN specifications and operations. So the RNP authorization requested approach, and the RNP 0.3, mainly for helicopter operations, are those that cannot be trained enough in the first place, so they need specific authorization or specific approval in this case. So just to highlight 4 things that are needed to utilize PBN, and this is 4 main ideas that this should be the starting point when talking about PBN utilization and implementation. The aircraft needs to be PBN approved. The operator needs to establish procedures for PBN. The pilot needs to be PBN endorsed, and the airspace requires PBN. I wanted to highlight this slide because normally when we face the challenges of implementing new technologies or new regulations in any aviation domain, we see that we need to involve all the stakeholders. And that's the reason why I'm really interested in having all the stakeholders together around the same table or in the same meeting room when that will be possible again, or around a screen like today, to be able to exchange different points of view, to be able to talk the same language, and to be able to share with the rest the difficulties and to see how we can improve together. We need to sit down and understand each other. From the regulatory part, it's very important to be in touch with the stakeholders and to know if they are understanding well, if the regulations are feasible, are manageable, and are well understood by the rest of the stakeholders. So if you see here, we are talking about the aircraft itself, operator, pilot, airspace. So we are involving a lot of aviation domains, and that's the challenge also from the regulatory point of view. And if you can see here, this is just for your information. We are not going to go into detail because we don't have time today, but you can see that there are a lot of requirements, and AMC is acceptable means of compliance and GM guidance material. You see that there are a lot of regulations, Yasa regulations affected. And when now with the new or the modern way of regulating, a lot of things get involved together when you are regulating, and the challenge is to find the appropriate part of the regulation to change it, because sometimes in the past some of the regulations were a little bit apart from each other, and now they are a lot more connected. And I think that at the beginning this presents a difficulty to understand the regulation, but once you do, it's easier and more convenient. So, well, you can see here the different navigation specifications. This is just to show you the different array of different procedures, flight procedures you have. You see that the challenge still to have more precision in the approach phase, because the precision you have in en route and arrival and departure procedures is sufficient, but when you get close to the terrain, you need to have a lot more precision, and that's still the challenge. And there are a lot of initiatives being tested, and some of them already implemented. But the ones to make the step of regulating them and approve them on a general basis is not easy. So you can see here the most precise ones are the ones that we mentioned before, that needed specific approval, the RMP-AR approach, and the 0.3 for helicopters are the ones that have more precision. So we'll continue to see an evolution of this, and using different systems like SBus, GBus, and a lot more. We will have more precise approaches like this ones. So this is again the last slide to show you that PBN affects a lot of provisions. We mentioned air crew and ops as the main ones, but also we have their airspace design, for instance, air information service, also the data. Also, I mean, you have the ATM network and others. So PBN is something that once implemented, from the moment that it was implemented, it started affecting a lot of aviation domains, and it has to be treated like that, because it's related to all the domains, and that's the challenge, and that's the interest we have to have all this relevant experts and stakeholders together. Well, that was it from my side today. I hope it was at least a decent presentation. I'm not an air navigation expert anymore, but I tried to do my best. I hope it was interesting for you. If you have any questions, I'll try to, hold on a second. I'll try to answer them later during the Q&A session. Thank you very much.
Yes, thank you very much, Carlos, also for stepping in for your colleague. I think it was a very, very interesting overview. Before we move on to the more technical side, two people have raised their hands, and I would like to have it as interactive as possible. So, Mr. Thakur, you raised your hand, so please come and switch on your camera, and yeah, ask your question, please.
Hi, Atul. Thank you. Thank you for organizing this workshop. Carlos, very interesting presentation. I just would like to know the JIBA's success rate in Asian countries, because I've heard that it is a temperature sensitive equipment. And is there any performance degradation because if it is, coming away from the equator?
That's a very interesting question, and unfortunately, I'm not in the position to give you an answer, but I will. But because I mentioned in the beginning that I was involved in the South Asia Partnership Project, and we are about to launch a new one. And in the last year, we delivered an activity. We organized an activity. It was to analyze and to assess all the ATM situation in South Asia, in all the 8 South Asian countries. And the experts came up with very interesting conclusions. The aim behind that, the ultimate goal, is to create a South Asian ATM master plan, following the example of the European ATM master plan. And there is a very high, good interest, I think, from all the states to work together in this field. There are a lot of solutions presented, and we will work on that in the future. And we need to go to the ground and to see if we, or the different systems that we can introduce in the ecosystem, the ATM ecosystem or the air navigation ecosystem in South Asia, because there are a lot of synergies between states. And regarding your question, I'll try to give you an answer in the future, but I don't have the answer now.
One more, Carlos, if you don't mind. The RNP minima, I would like to know what will be the difference in the minima of RNP approach, especially when you don't have ILS system.
So
what
the thing is, you are only able, as far as I remember now, to have category 1 approaches using vertical navigation based on RNP. So the minima would correspond to those of category 1, the ones of category 1 ILS. I think there are systems being tested to improve those minima. But as far as I know, and I'm not 100% sure, the minima you can achieve now is category 1, and the ones similar to category 1 ILS.
That is without ILS, localizer or glide path, right?
Yeah.
Right. Thank you.
Thanks, Carlos. We have one more question from Mr. Gopal. Mr. Gopal, you are there? Yes.
Thank you. I'm Gopal Bishan. Right now I'm sitting in Bamako, Mali. My question is, in European Union, do you still ensure that in air operator certificate, it is endorsed, say, RNF 5, RNP approach authorized? I'm asking you this question why? Because we have an air operator from the Russian Federation, and in their air operator certificate, he has an endorsement of RNF 5. And in Mali, we have PBN approach charts. They are non-precision. They require RNP approach. And this air operator still carries out PBN approaches on those airports, despite our concerns. So to skirt around, what they have done is they have changed their operations manual. If the minima is 1.6 kilometers visibility requirement, in the operations manual, they have made 2.5 kilometers, and operations manual is endorsed by CEA, that's the Russian Federation. So now to carry out a task, they are skirting around rules, like in air operator certificate, there is RNF 5. In operations manual, they have given a procedure that they will carry out a PBN approach with a higher minima. The published chart is say 1.6 kilometers, but as per their operations manual, they have made it 2.5 kilometers. So I want to know like your opinion on this. Should we need to take this issue with say Russian Federation or European Union? What should we do now?
And that's a very good question, and there is no specific answer for now. The problem was, from my point of view, that in the past, this happened also in Europe. All the aviation authorities had the power to legislate and to implement their navigation regulations, and the procedures were similar, but no, they weren't identical. So when you find a specific case like that one, you can take two different paths, and you can try to solve the high-level issue, which is how we are going to do, how we are going to, let's say, approve different approvals or different requirements from other regulators, or try to make a specific assessment, safety assessment for this specific case. So my recommendation would be, from the authority point of view, you need to assess if the operations manual is clear enough, if the pilots are trained enough to know exactly what they need to use, what the minima are. Because otherwise, if you give approval to that and you're not 100% sure that they are going to follow the appropriate procedure, to make it simple, this is not going to be safe enough. So you wouldn't be in the position to approve it if you don't have enough evidence that they have a clear instruction of how to perform. So we would need to analyze this that example in depth to see if it's appropriate, and that should be included in a safety assessment.
Okay, we need to do more homework on this. Thank you.
Thank you, Carlos, for the answers. Carlos, as you said, regulations are there to keep us in shape and to regulate safety, but the industry, we need the industry on board as well, and we also need technology that comply with these regulations. And I'm very happy to have Géraud and Stéphane, Géraud from ATR and Stéphane from NavBlue here, who will do a presentation on performance-based navigation. Please come on board on stage and share your screen. We are very, very interested to know the technical side of it. Géraud, you are muted. You have to unmute yourself, please.
Okay, I thought I did. Is it okay now?
Yeah, now it's
okay. So thank you, Atul, and good afternoon to all, and good morning to the ones in Europe. My name is Géraud de Rivals. I work for ATR as the Flight Safety Director in order to spot where safety can be improved. My role is to identify where we can improve safety, either at the level of the operator or at the level of the fleet, which is the reason why I'm very happy to be here today and to promote performance-based navigation in this workshop. PBN, as already explained by Carlos, requires a lot of cooperation, which is the reason why I'm happy to share this presentation with my colleague Stéphane Morel from NavBlue. So over to you, Stéphane.
Thank you, Jérôme. Good morning, good afternoon to everyone. So I'm Stéphane Morel. I belong to the Airspace Solutions team of Navblue. Navblue is an Airbus subsidiary. Navblue has gathered in the past 10 years extensive experience around PBN procedure implementations. We have been working a lot with Airbus, obviously, but also with ATR. And I will be happy to share some of that experience in the coming slides. Okay, so maybe let's start this presentation by setting the scene based on some ICAO statistics. The figure that you see on this page is showing accident statistics per flight phase for a period in between 1997 and 2016. So ICAO statistics showing, I mean, let's say the rate of accident occurrence per flight phase. So from parking, taxi, takeoff, run, initial climb, until the approach, landing, and go around. And what is obviously striking on such a chart is that combined together, approach and landing are respectively associated with 20% of hull losses for approach, 45% for landing. And at approach, more specifically, you see that the darker part of the block for the approach statistic shows that more than 10% of these incidents have proven to be fatal accidents. So, needless to say that for the industry, for us, Navblue, Airbus, ATR, approach and landing are definitely target faces. And well, we believe and we are convinced that PBN is let's say is a key enabler to improve safety. Why is that? Because based on the on ICAO studies on CFIT. So CFIT standing for Controlled Flights into Terrain. Runway aligned approaches with LNAV only, LNAV means lateral navigation, are 25 times safer than circling approaches. 25 times. And in addition to that, once you bring some form of vertical guidance on top, the safety margin is further increased by a factor of 8. So you see that as soon as you bring in some automation, some vertical and lateral navigations, the safety benefit is going to be tremendous. The next to you, Jérôme.
Sorry, I'm having some trouble to go from one side to another. Okay, thank you. So thank you for this first background. Here, I would like to show you what we can find from the ICAO website itself. As you know, as it was already explained by Carlos, PBN has been implemented by it's an initial initiative from ICAO back in 2004, and then ICAO gave the mandate to each and every state to publish a PBN implementation plan. Here you have the status. You can go to ICAO's website and track the status for each country. So here in India, if you look at all international runways, which means 20 airports, you have a status. So it has started in 2017, more or less, and now you have a good number of LNAV and VNAV implemented. Some airports, like for instance, Indira Gandhi International Airport in New Delhi, has no PBN approach published yet. Some other, like in Bangalore, they have 50% of their approach in PBN, and some other, like in Jaipur, it's all PBN already. So it's coming. It's still some work to do, but it's coming. But what I want to highlight here is that we're talking only, if I may, we're talking about 20 airports, because we are talking about international runways only. And this is the message that I have already personally given to ICAO. The mandate is possibly not pushy enough. And I would like now to have a look at what is done in India. And of course, you are more familiar than I am regarding the UDAN scheme. You can track the UDAN status on this website. So this website was updated end of November. We are talking now about 299 routes in UDAN. So UDAN, of course, the aim is to connect remote populations. Within these 299 routes, we are talking about 86 airports, not 20 anymore. And within these 86 airports, we have 31 airports with no instrumented approach published yet, not even talking about PBN, no instrumented. So these 31 airports are VFR only, visual only. I've excluded from these numbers, I've excluded heliports only. So the scope is pretty big, and this is the reason why we want to promote PBN, especially in India, especially within this UDAN scheme. It's because, as it was already discussed and previously mentioned by Carlos, we don't need anymore to invest in heavy ground navigation aid. This is the beauty of PBN. We are talking about satellites, which are already up there. So what we want to do, if we want to turn VFR into IFR, which is of course far more safe, we simply, if I may, have to design an IFR approach and turn, of course, the airfield into an IFR airfield. So now that we have set the scene of why do we want PBN, let's come back a little bit on what PBN is. What is it? Okay, this was again a little bit explained by Carlos from EASA, but let me come back on some basics for PBN so that we all agree. Of course, we have only 30 minutes. We are not here to become all of us an expert in PBN, but just to agree on the terminology. So this was created by ICAO in order to harmonize a set of navigation requirements and specifications. This is based now, it's no longer based on the accuracy of the ground navigation aid on ground, such as ILS, VOR, DMB, NB. No, now this is the aircraft itself, which is able to compute and to assess the accuracy of the system, of the signal which is received from the global navigation system. So this is the big change, is that now the accuracy, the integrity, the continuity, and the availability, which are the 4 pillars for PBN, all these 4 pillars are assessed by the system itself. And then within this set of navigation, of specifications, we split these in 2 main families: AirNav, which stands for area navigation, where onboard performance monitoring is not required, and RNP, which stands for required navigation performance, where onboard performance and alert is required. It means that the system itself would trigger an alert to the pilot: be careful, you don't meet the required navigation here anymore. So when we say AirNav 1, AirNav 2, the 1 or the 2 refers to the lateral navigation accuracy in nautical miles. So to answer a question which was already asked by Mr. Gopal, if I'm correct, AirNav 5 means that the system guarantees that the aircraft knows the position within plus minus 5 nautical miles. This is what it means. If I look at the global scope of PBN now, we can find PBN all across the flight, from the departure RNAV1, RNAV2, or RNP1. En route, so of course you don't need as much precision when you are en route, and you can even find RNAV10 or RNP4 for very specific areas like oceanic or remote areas where you don't have a lot of ground navigation aids to calibrate better the signal. Or as soon as you start the descent, then you need a better accuracy, RNAV1, RNAV2, RNP1. And now talking about the approach, we are entering the RNP approach family, LNAV, VNAV, LPV, or RNP-AR. For these approaches, as a minimum, you need 0.3. So to answer your question, Mr. Gopal, RNAV5 is not acceptable from my point of view, not because of the training of the aircraft, of the pilot, but the aircraft itself needs to be RNP approach approved. So it needs to be stated on the aircraft manual that the aircraft is able to comply with RNP 0.3. This is the big part. Here today we will focus on the approach phase, even if PBN, as you have understood, is all along the flight. On the approach phase, let's focus now on each subpart. LNAV, of course, stands for lateral guidance. VNAV is lateral plus vertical. And so just for your understanding, and that was a question raised as well. I think it was Mr. Tako, if I'm correct, to assess the minima. The minima, usually LNAV have higher minima than VNAV simply because the way the approach is designed. LNAV is a two-dimensional procedure, which means that when you design this approach, you have to select the higher obstacle in the approach, and then you add a margin and you draw a line or you draw a plan, and you need to have your approach above this plan. As opposed to VNAV, which is a 3D approach, and you don't need a plan above the highest obstacle. You have to design your approach within a corridor with the same margin. So if there is no obstacle at all, LNAV and VNAV would have the same minima, which is the lowest possible, if I'm correct, is 250 feet. But then it depends on the obstacle. And you can see from this graph that, of course, if you have a high obstacle, but which is pretty far from the runway, it will hit the margin for the LNAV, but it will be okay for the VNAV. I hope this is clear. Otherwise, I can explain a little bit later. Then on the difference with RNP-AR is that it's exactly the same as VNAV, but then you can design some curved approaches even beyond the final approach fix. This is very convenient when you have some obstacles, of course. And last but not least, this is LPV, which is, as explained already by Carlos, this is ILS-like, category 1 only. It's not yet approved for category 2 or category 3. It's category 1, which means down to 200 feet minimum, but again, it depends on the obstacles. But you need to have a SBAS, satellite-based augmentation system. You need to have a SBAS coverage, which is true, which is available in India. It's, as you can see on this map, it's not available everywhere, but it is available in India. This is good news. The big difference between LPV and the other is that you need 2 GPS or GNSS receivers on board. Same for RNP-AR, by the way. But here you do not rely anymore on the barometric altitude. You have the approach is designed and the aircraft is guided along a path which have the reference across the ground, not anymore the baro. So you don't rely, you don't depend on the atmospheric condition. You don't depend on the QNH, on the pressure and the temperature, which is a big benefit, of course. Okay, some focus now on vertical navigation. So as I explained earlier, vertical navigation, you would be guided through a pipe, a corridor, which guarantees a minimum margins within this corridor, which is much safer. It means that you can easily turn any 2D approach into 3D. This is, again, the beauty of PBN. Even existing 2D approach, such as VOR DME, for instance, you can fly this with vertical navigation and benefit from vertical guidance coupled with your autopilot. So it means that you would be guided through the whole approach thanks to your FMS. You don't, of course, you will have still to keep VOR tuned in order to check the signal, but the FMS would guide you thanks to the GPS position, GNSS position. It's a continuous descent with reduced workload for the pilot, which is great safety benefits. In terms of benefits, as I explained, VNav would optimize the vertical path. The FMS would compute for you the optimized point of descent, which in average would save 2 minutes of flight time, which represents 60 kilograms of CO2 and 20 kilograms of fuel. So that's a safety benefit, as I explained, because it's reduced workload, and you can couple this with autopilot, but it's operational benefit as well, with significant improvement in terms of environment and in terms of pricing. 20 kilograms of fuel is more or less $9 if I take these numbers, which were given mid of July last year, and $11, 2 minutes for us in ATR, it represents $11. So in average, it's $20 per flight, just a rough order of magnitude. Localizer performance with vertical guidance, LPV, I explained already. So you need to have the coverage, which is true in India. And the big advantage for the airport facilities is that you have the same accuracy, category 1, but you don't need to invest or to maintain heavy ground and costly ground navigation aids. You don't need this anymore, and you have the same capacity down to 200 feet for the same result. Over to you, Stéphane.
Yes, thank you, Jérôme. So let me further explain and expand on the benefits of performance-based navigation. So as already said, safety enhancement comes at the top of this list, obviously, especially when it comes to navigating in challenging environments at approach. But there are also other beneficial effects in terms of airport accessibility, in terms of fuel burn reduction and payload increase, in terms of airport capacity increase, and in terms of sensitive areas avoidance. So I'm going to support each and every of these items by one concrete example, starting with, let's say, the safety brought by PBN, and more specifically by RNP-AR at Kathmandu in Nepal. So the picture that you have here is showing Kathmandu runway at the bottom of the valley, and you can also see a number of flight tracks representing approaches and landing on runway 02. So there is a first group among these flight tracks. Jero, one click, please. Yeah, this one. This one here corresponds to what is currently operated without RNP-AR. That means that right now the aircraft is approaching straight in and have to overfly the mountains, which means that the final approach gradient is quite steep. Today, the published gradient on the non-RNP-AR procedure is equal to 5.31 degrees in the final stages of the approach. So 5.3 degrees is quite steep. And the beauty of RNP-AR is that it makes it possible to significantly decrease that gradient. How is that? Let's have a look at the second batch of flight tracks. So the one pointed by the green arrow here. So that may not be so visible on this screenshot, but the RNP-AR approach at Kathmandu is indeed navigating basically in the middle of the mountains. This was already explained by Géraud on one of his previous slides, but basically this procedure will ensure that the aircraft safely navigates in the middle of the mountains, so below the top of the mountains, in the middle of the valleys. What does that mean? That means that well, the final stages of the approach are going to be initiated with let's say a lower altitude, which will in turn means that the final approach gradient is going to be much smoother than the initial one. And today, the published RNP-AR approach at Kathmandu runway 02 is associated with a 2.8 degrees, so to be compared with the previous 5.3. So obviously, needless to say that, well, this is going to, let's say, to be a significant contributor in reducing the CFIT, the controlled flight into terrain incidents. But it will also make it possible to, let's say, to perform approaches which are going to be consistent, predictable, and much more stable. So all of that is definitely very good and very beneficial for safety. Let's have a look now at how PBN can improve accessibility. So I will bring you to, let's say, to Vagar Airport in Faroe Islands. These are islands located in North Atlantic. The picture that you have here is showing what the approach is looking like when operating non-RNP-AR. So you have already a clue, thanks to this picture, of how challenging the local environment can be. It's really located north of the Atlantic, so that means low latitude. So that means fog, rain, wind, and turbulent wind. So on the left-hand side, you have a view of well, what the approach is looking like from the cockpit, from the current visual acquisition point. This is shortly described on the sketch below on the left-hand side. So the aircraft is following, let's say, the blue line. There is a visual acquisition point somewhere, so slightly to the left of the runway. And beyond that point, well, the pilot is on his own. He has to, let's say, to perform kind of a tricky manual maneuver to manage this offset. And well, that's something which is not so easy to manage. And this is typically the type of tricky maneuver that the RNP-AR is going to solve. This is what is displayed on the right of the slide. Again, you have the picture of the runway at the new visual acquisition point once an RNP-AR is operated. So you see that thanks to the automation and the accuracy and integrity of RNP-AR, well, it's easy to automatically bring the aircraft to a visual acquisition point, which is going to be closer to the airport and fully aligned with the runway axis. And in terms that will mean that approach minima are going to be much lower. So you see that based on this example, RNP-AR is going to change the deal and turn a situation where the approach is tricky and maybe not that easy to perform for let's say each and every pilot into something which is going to be much more straightforward, thanks to the automation, integrity, and accuracy of PBN navigation. Third example is based on Cape Town Airport in South Africa. It's going to highlight how PBN can contribute to fuel burn reduction, or to put it differently, to payload increase. The figure that you have here is showing. So the red track is showing what the conventional procedure is looking like at Cape Town. So the arrivals are coming from the northeast part of the figure, and if you follow the red track, so you see that as you go along this track, you have to perform first a very sharp right turn, followed by another sharp left turn to get finally aligned to the runway. So you see that in terms of track miles, this is not so obvious. So that's to be compared with the green track, which corresponds to the RNPAR procedure implemented at Cape Town. So following the same track, so approaching from the northeast, you see that well, the aircraft is going to be navigating in much straighter line from the let's say the initiation of the approach down to the runway alignment. So compare that with the red track, and it's immediately evident that well, it will represent less miles. That means obviously less fuel burn or more payload, if you will. In addition to that, well, the same principles I previously described at Kathmandu, for instance, will still apply. The descent is going to be continuous. That means no level off, no need to decelerate or accelerate to maintain a given path. Continuous means also that it's good for fuel burn. Next, Joe, please. Okay, so increase of capacity. So you have here an example of what the terminal maneuvering area of Bogota is looking like after PBN implementation. So this picture is showing that, well, a number of tracks well defined, and this pattern is relying on a given number of waypoints or entry points. And again, all these routes are going to be, let's say, operated in quite a predictable manner. That will make it much easier for the air traffic control to manage the incoming flow, because the pattern and the scheme is set, and it's basically a matter of let's say making sure that the aircraft are following these tracks in an optimized manner. So that means much less vectoring and a significant reduced workload for air traffic controllers. So the bottom line of that is that it will be a significant help for the ATC to manage and to deconflict arrivals versus departures. So you have here a couple of figures. After the redesign of Bogota TMA, the capacity of runway 13 was increased from the initial 72 movements per hour up to 93 movements per hour. On the other runway 31, let's say the improvement is even more impressive because from 30 to 68 movements per hour, PBN implementation here has more than doubled let's say the runway capacity versus what was existing before. All right, and the last example highlighting the benefits of PBN is showing how it can, how the flexibility in designing RNP procedures, for instance, how it makes it easy to avoid any sensitive area. So here we are focusing on Brussels Airport in Belgium. So basically, Brussels is in the middle of the yellowish circle that you have on the chart. Well, this is a populated area. This is an area where you want as much as possible to avoid noise nuisance. So this is an area to be avoided. And you see how let's say the blue trajectory, which corresponds to PBN approaches, easily and smoothly avoid this sensitive area. And making sure that the access to Brussels runways is adequately performed by avoiding flying within this yellow zone. So in addition, it's also a good means to reduce holding times, by the way, and to make sure that the flight path within the TMA are also to be as optimized as possible. All right, so we have had a glimpse of the many benefits of PBN, zooming mostly on approaches. But to put that into a larger perspective, let's spend some time on a wrap up and conclusion about that. So this chart here is mirroring one of the slides shared by Carlos previously. This is highlighting the fact that PBN is a matter involving several stakeholders. That's a multiplayer scheme, and the stakeholders in there are the GCA, so the authorities as regulators have obviously a key role to play. ICAO as let's say a global entity. Air traffic controllers, because they will be in charge of making sure that any PBN or RNP approach smoothly fit within the rest of the traffic, which may be conventional or visual. Aircraft manufacturers, they will be the one making sure that very aircraft are capable of the targeted PBN specification. So that will be the technical side and for the eligibility to PBN operations. Air navigation service providers also. They are usually the ones in charge of designing procedures and charting them. So they are at the core of the design and validation process of a given procedure. Do I need to insist again on airports? I believe that the examples that were described before highlighted the fact that airports is a cornerstone in all PBN operations. Same statement for airlines. I mean, they are at the let's say the end of the line when it comes to operate RNP and PBN procedures. So it will be up to them to make sure that the aircraft is fit, that the training.
Excuse me, can everybody mute himself except the speaker, please? Thanks.
So I was explaining that it was obvious that airlines were at the end of, let's say, the operational pattern of PBN. So they will be, it will be up to them to make sure that they apply via an adequate operational approval dossier that will properly document the aircraft eligibility, any training program, any impact, and any let's say requirements to be properly documented in operations manual. So you see that's a full ecosystem. Each and every stakeholder has a has a role to play in there. And successful the key for a successful PBN implementation is making sure that everyone is on board and finds their place within this scheme.
Thanks, Stefan. So last slide of this shared presentation. So we have explained and highlighted some benefits in terms of safety, where you can, maybe not easily, but it's easier than it used to be. You don't need to invest in a heavy ground infrastructure, ground navigation aid, to turn VFR into IFR. In terms of ground infrastructure, you need, of course, to turn the airport into an IFR airport, and then it depends on the local authorities what they mean by that. Yeah, for the minimum that you need for instance, for VNAV, is to have at least the QNH, the barometric pressure given to the crew. So it's not heavy ground infrastructure that you need. It reduces the workload during the descent, reduces the risk of controlled flight into the rain. It is cost effective, and of course you can improve the dispatch of your flights, and it's environment friendly. And as explained both by Carlos and by Stefan, it requires a lot of cooperation, of course. If you want to fly PBN, of course the aircraft needs to be PBN approved, so it needs to be stated in the flight manual which PBN capacity this aircraft is approved for. Is it RNP approach? Is it RNAV 5, etc., as I explained earlier? For the operator, the pilots need to have the PBN license, endorsement on their license, and the operator needs to adapt their procedures. And of course, for the authorities, the airspace needs to be PBN designed. So this concludes our presentation. We received in advance some questions, which I have copied paste in the presentation. So Atul, if you don't mind, maybe I will simply display some questions that we have received. If it's fine with you.
Yes, that's perfectly all right. I actually did that as well on an Excel sheet, but please go ahead.
Okay, so first question, and I believe this was already answered, or at least asked to Carlos, and I already answered this question. I don't know if Mr. Gopal, sorry, is okay with the answer. So RNAV 5 on the AOC is not enough to perform RNP approach, because you need to have RNP approach stated in the flight manual, and of course flight crew needs to be trained as well. On the PBN approach, on the other hand, I don't know, Carlos, if you want to answer to that question, or Stefan. From my point of view, it's not linked to any VOR, DME, ILS. It's if you are PBN approved, you are PBN approved, whatever the means of the ground navigation.
Yes, sure, you're right. And to complement what you said, I mean, there is no let's say no issue in fitting an airport with a PBN approaches, even if there are no other AirNav aid available. You just want to be sure and to take care of, let's say, the availability of QNH information on this airport, and the fact that this airport is instrument capable. It's capable for instrument approaches.
Okay, thanks. Now another question. Yeah, most of the RNP approaches does not confirm with PAPI. Let us know the reason. So maybe Stefan, you can explain this slide that you gave me earlier in order to answer that question.
Mm-hmm. Yeah, sure. Well, this question is related, or let's say, calling let's say a remark about what is really specific to PBN operations and to RNP approaches in general. They are both relying on, let's say, on what we call baro-vnav. That means that let's say navigation is going to be performed based on barometric information. So typically pressure. That means that if we have a look at the figure here, well, we have let's say several profiles. The one in the middle, the red one, would correspond to what is duly published. So generally, that's associated with an average temperature at the local airport. The other two lines in orange that you can see here represent what this published profiles turns into at cold temperature and hot temperature, because, well, generally these operations are performed on aircraft for which there is no temperature compensation. Some of them are capable of that, but most of them are not. That means that the flight management system, FMS, of the aircraft is basically using standard temperature information. That means that there is a sensitivity of the vertical profile to the temperature. For instance, when the temperature is going to be colder than the temperature for the published profile, the true altitude of the aircraft is going to be lower. It's the opposite for hot temperature. The true altitude of the aircraft is going to be higher. So you see that when having a look at let's say the final segment, the approach segment of a given procedures, the actual approach gradient is not going to be exactly the same whether you operate at cold or hot temperature. So usually, well, it's the answer to that is going to be slightly different from one airport to another. But when flying the published profile, this is where you would expect to, let's say, to be aligned with the PAPI information. So that means that you would have 2 red and 2 white lights in general. But if it's a bit hotter, you see that well, you will be slightly above this profile with a higher gradient, which is okay because the design has been tailored in such a way. But that means that it's true that let's say the alignment with the PAPI is not going to be the same as for the published profile, and that's normal. And that's something that obviously an airline and the flight crew has to be aware of, but that's no issue because that's typically that's specific to this baro-vnav operations.
Thanks, Stefan. That's very clear. So in other words, if I summarize, even if you fly strictly the baro-vnav, if it's hot, you may have 3 whites. If it's cold, you may have 3 red, but it's fine because it has been designed this way. Okay, I think we already discussed this. Okay, RNP approach at VFR airport. I think this is precisely the reason for this workshop. Yes, of course we can, but it means that the VFR airport has to be turned into IFR airport. So over to your local authorities to assess what DGCA means by IFR airport. Depends on the authorities, as I said. What would be the minima? Well, this depends on the approach, whether you design an NNAV or a VNAV, and it depends on the obstacles. So the lowest minima you can get is 200 feet with LPV, provided you have no obstacle at all. And then it depends. I cannot answer to each. It depends. Missed approach procedure in India are very long. Could it be looked into? Maybe Stefan, again, as a procedure designer, specialist in NavBlue, you can explain, but I guess one by one, you can see whether this procedure can be fine-tuned. Depends.
Yes, indeed. That would be a case-by-case analysis. But let's say the missed approach procedure by design is part of the game. The missed approach is part of the design process. That means that the missed approach track is somehow protected, and there is a way to let's say to implement flexibility in this design in accordance with let's say the local environment. So in principle, the answer is yes. There is room for shortening the missed approach procedure in the limits imposed by the local terrain, environment, and obstacles.
Okay, thanks. Last question. Wait.
Jérôme, Mr. Surinder Pal Singh has raised his hand, so maybe I could take that question from him, please.
Yes.
Mr. Singh?
Yeah, thank you very much, sir. Sunil, sir. Okay, my question is that we were talking about one is the PAPI does not confirm. This question was raised by me. I want to know, can we have it depicted on the chart that the PAPI does not confirm, because all the PAPIs are mostly 3-degree aligned ASA, and normally these approaches are not 3-degree, maybe 2.9, 2.8, 2.95, 3.1. So can we have such system where we can depict it on the chart, that, and the regulator is also aware of that PAPI will never be in conformity with this approach, the approach which has been designed? This is first question. You can answer this, and then I'll continue with the second question.
Maybe it never is a bit strict. Sometimes the PAPI is compliant. This is a question for the regulator, whether how they want to assess this in the chart. Stefan, you know the answer to that question?
No. Again, I mean, you're right in pointing out that well, this should be within the hands of a regulator. This being said, I'm not sure that the chart is let's say the best support for that. I believe that let's say the global awareness around RNP approaches, and the fact that well, it's normal that you don't have necessarily 2 whites and 2 reds on the PAPI. For me, that's probably the best way to let's say to communicate and to create awareness around that, by training and making sure that everyone is aware of this specificity of the PBN. But again, it's well, it's in the end within the hands of regulators.
It's true. It's the very reason why we insist on the training, by the way. You had a second question, sir.
Thank you very much, sir. And the second question is, you said that yes, you can have RNP approaches on VFR airfield. This is one which I wanted to hear from you. Secondly,
if I may correct, you can design an RNP approach at a current VFR airport, but then this airport needs to be turned into an IFR approach.
Okay, but if it is on the VFR runway, then I can use those approaches with minima of 5,000 meters, which is a VFR requirement. Is that correct?
I'm not an expert on that, but I would say no. If you fly an IFR approach, for me, it means that the airfield is IFR. So if you are flying an RNP approach, it means an IFR approach. It means that the airfield is already IFR. For me.
I support this statement.
Okay, thank you very much. No more questions.
Thank you.
Thanks a lot.
And then,
yeah. Okay, please go ahead. Because we have so many questions also aligned here in the chat, but please go ahead. Yeah.
So this question is on helicopters. So I asked Shankar from Airbus Helicopter to join the call. I hope he's there because I cannot answer myself these questions. So Shankar, are you here?
He is there, yes.
Thank you.
Yes. Hello. Can you hear me?
Yes, we can.
We can hear you.
Great. Thank you for letting me take on this part. A great presentation, and I'm sure there were some questions around the helicopter part. Let me take the first one. The first one is the regulations on approval of RNP.3 operations by helicopter operator. Now, as you're all aware that if you go by the process part on RNP approval is quite clear. The process has to follow the same standard 5-phase process, which is the pre-app, app, then the documentation, then demonstration, inspection, and finally the approval. This is as far as one could say as the process is concerned. Now, if there were one has to ask that the concept behind this would be actually, let me put it across, is actually working on 3 different parts. The operational approval around this would be, the 3 parts would be A, on the airworthiness part, on the continued airworthiness part, and of course the flight operations part. And for the airworthiness part, when you are seeking an operational approval, the operator would be checked and seen that does the aircraft requirements, does it mean the function, the performance, the installation which is supposed to be there, the design standards for this particular RNP.3 is available or not. So that would be what would be there on the airworthiness part. On the continued airworthiness part, they would be about is the maintenance schedule, the configuration management, the test equipment, the training, the competency of the people working on this equipment would be forming as far as the second vertical on this operational part will be concerned. The third and the final vertical for the operational for this operational approval would actually go around the part for the flight operations, and the flight operations one would be things with concerning the operator, that does he have operating procedures which is laid down by him, what are the route guides, what is the MEL, what is the training, what is the competency of the air crew, and as you have heard that you need an endorsement, a PBN endorsement to fly these PBN routes. So there's a competency around it. And of course, there is a recurrent or a continued competency also around this part. So if you satisfy on all these counts, on all these airworthiness, continued airworthiness, and flight operations part, go through the process, which is a 5-phase process, and therein one could achieve the operational approval for RNP.3 operations. The other question was for around SNI, or simultaneous non-interfering operations. Now, SNI operations have actually come out recently. It's not very recent, but okay, there is work going around this thing to make it a more reality. It all comes around this fact that since we do have PBN and there are greater precision available now for aircraft to be maneuvering inside in the airspace and a greater air traffic control which could be exercised because of PBN. One question which had actually popped up is this: that why can't we have the helicopters and the fixed wing utilizing the same area or same landing zones on a simultaneous operations? So this was the key part where the SNI thing came up from. And of course, SNI is also there are 2 key plus points which everybody is looking out for if SNI goes through. Is around one is of course helicopters make a lot of noise, so it would be one, could we have these SNI procedures which could be developed which decreases noise? And the second is, of course, like I said, can we increase the throughput? So that's the 2 things. So in fact, there are 2 studies which are already going on. One is called Garden, which is on the GNS-based ATM for rotorcraft to decrease noise. That's a study on that part. And the other one is called Earth, which is enhanced runway throughput. So these are the 2 things which are going on. And of course, for Airbus, being led by the Airbus commercial arm, we also have the 4D TBO, which is trajectory-based operations, which is also there. I mean, these are concepts which are bound to become a reality in the coming years, in a very soon future. The next question was where to find pins, approach plates for proceed visually and proceed VFR in EU airspace. Well, fine. There are, especially in Switzerland, which has been a lead to develop the pins procedures. Yes, the approach plates are available, and separately, whoever asked this question can reach out to me, and I could probably send you the approach plate if one needs to see on the proceed VFR and proceed visually sections. I'm sure that one understands the key difference between proceed VFR and proceed visual sections. So there is a little bit nuance around that part, but this could be taken up later on because I know we are running short of time. The next one is how do we approve PINs procedures in class G and F airspace? I will not take F. Let us take F in the bunch along with the D and E. Basically, why I'm saying that we take it along the bunch with D and E is because in both these cases, some form of ADC service or flight information service is available. In Class D is a completely unregulated one. Class D does not have a flight information service. You need to request for it. And also the other difference between Class D is this, that there is no need for ADC clearance. Now, if you have to design a PINs approach around the Class G airspace, the key part around this thing is to avoid the mid-air conflict with the other traffic, because you would not be having typical ADC clearances around this part. But of course, radio communication would be mandatory in this case. In fact, that's why we do have something which is also known as radio mandatory zones. So even though helicopters might be flying lower and they could say that I'm in a Class G airspace, but having mandatory radio communication on certain areas, especially at the first initial segments, both at takeoff and during approach, would be mandatory.
Just a short intervention from my side. We are 3 minutes before our meeting ends, but since this is we are in the flow and this is so interesting and we have so many questions lined up, I wouldn't mind to extend. If everybody is okay with that, we'll continue. But I have to ask my speakers here as well from our cluster. Are you okay to take this further for a few minutes, or do you want to continue?
I'm fine myself.
Yeah,
for me, it's okay too.
I'll take about 3 or 4 minutes for tackling these questions. Thank you.
Okay, so we'll add another 30 minutes. My communications team, I'm apologizing to you, but this is so interesting and we are in the flow, and I don't want to just abruptly terminate this session. So please go ahead.
So tackling the same helicopter question, another question around this part, I think what it perhaps means is that if you're doing RNP 0.3 on a helicopter, and typically helicopters fly at a lower altitude, there is bound to have a limited VHF communication. Now the question being asked is that is the procedural method acceptable for traffic separation? This means that essentially what is being asked is this, that in a certain segment or a certain part of this entire route, there might be certain areas where VHF communication is not available because of obstructions surrounding obstructions or the terrain which precludes the VHF communication. Now, in this case, could we have some entry and exit points? Now, the answer to this is this, that if you are doing any kind of RNP approaches, and especially any kind, in fact, two-way radio communication is a mandatory thing. Okay. Now it is known fact that yes, because of the low altitude of helicopters, and there could be a LLR, low-level routes designated for helicopters. It could be that in certain areas VHF communication may not be available, but yes, you cannot design one which says that there is an entry and exit points, and this is procedurally driven without any radio call. No, there would not be there. Two-way communication is mandatory for this sport. The second question was that can this RNP route, 0.3 route, can we connect to any other routes for seamless connectivity? Yes, most certainly you can. The RNP 0.3, which is developed on a PINs procedure, basically can feed you into approach, which means that it takes you either to a MAPT, missed approach point, or it takes you to IDF on a takeoff leg, which is the initial departure fix. You could have a procedure which is designed, which feeds into these either things, and have a PINs procedure along it. So there can be a seamless connectivity, yes. The next question was, it may be accepted that heliports shall be largely unmanned, even though IFR compliant using PINS procedures. What restrictions are recommended? And so basically the question is that, can helicopters have their own traffic separation? Well, it's a corollary to the first one. No, you need to have a two-way communication around this part. So no, you could not have a two-way traffic separation right from the start, because essentially there would be a safety risk around this part for a mid-air collision. The key part about not having two-way communication means that you are akin to operating on a Class G airspace where no restrictions apply, and you do not even have the advisory services of what the traffic is going around. So yes, there are challenges on this part, but own traffic separation is not permitted. Our AWS or AWOS actually, AWOS, automatic weather observing stations, yes, they are accepted. Yes, AWOS can feed into the national weather system, and yes, AWOS could be giving a data information and feeding into the national weather system. But so long as the AWOS is certified, in fact, FAA has an advisory circular around this and a process as how to obtain the certification around this part. So the information, weather information which you are receiving from AWOS is perfectly acceptable as far as the regulator is concerned.
Thank you very much.
And congrats.
Thank you.
Thank you very much.
I'm sorry I had to rush it so that I needed to give time to others. So if there's anything else, please do let me know separately.
Yes, we will definitely. So we have a couple of questions aligned here. There's a question for NavBlue. How can private airport operators add value to get PBN approaches in their respective airports if the ANSP and the government-owned are government-owned undertaking, especially in India? Who can answer that question?
I love that question myself. It's the very reason why we have set up such a workshop, actually.
Yes. And I think I can answer the question. See, we as the EU-India aviation cluster, since this is a multi-stakeholder and a multi-player scheme, we as a cluster, we are working with the governments, we are working with airports. We have technology providers on board in our cluster who can implement these technologies and procedures. We are working very, very close with EASA and the Southeast Asian Aviation Partnership Program. Also aligning with CESAR, which is a research program on ATM where PBN is a part of, a big part of. And since we are also very highly supported by ICAO, I think this cluster can really bring all stakeholders together in order to form strategies on implementing, in order to have timelines. And if I look at the UDAN scheme, yeah, if you look at the UDAN scheme, and there are 300 more airports coming up, not only in easy to fly in terrains, but also on high altitudes, on more rural areas, on approaches where you have to fly through terrains and higher altitudes or whatever. We can support that, and we can go step by step in order to implement that. And to be honest, the prerequisites are given in India, because the prerequisite is that we have satellites that are communicating with the airplanes, and the prerequisites are given that India is covered with that. So the strategy would be that we, as the working group itself here, we approach the governments, we promote the plan, and we also place a strategy on how we as the cluster can support Indian governments, airports, and also policymakers in order to implement PBN. I think from a cluster point of view, this is the answer. And from the technical point of view, of course, NavBlue and ATR, it's your call. Does this answer your question? I hope so. Okay, Carlos, you raised your hand.
Yeah, just if I may add, this is a very good question. What added value we can have implementing this type of operations? Well, first of all, you can change your airfield, your airport, your aerodrome from VFR to IFR, and that gives you a lot of more possibilities. But then you need to assess what you want by implementing this type of solution. So we are facing the very specific cases. We have the tools, and then we need to see if they are useful because there is a tendency to think that, okay, we have these procedures or technologies or I don't know, developments, we need to implement them. Okay, let's see if it's useful, if it's necessary, if it's going to bring you benefits, and then we can see what to implement. Just to give you a reminder, we were talking about the benefits of all the PBN approaches, in particular when we are talking about more achieving more precision. And if you remember, most of you could be familiar with it. ILS is the most precise system we have, and it was developed in 1940. So 80 years ago, and we are still using it. So there were other solutions tested. There was a very infamous, I would say, MLS, microwave landing system. That system allowed to have curved approaches, a lot of more flexible approaches, a more increased number of airplanes approaching at the same time to a runway. But what happened with that technology? That it was expensive and nobody wanted to invest, and it was kind of abandoned. There was an initiative 14 years ago to relaunch it, but nobody paid enough attention to that because they want it was necessary to invest money. So what happened? We have the satellites. The satellites are there. Let's make advantage of them, and then we'll see how we are able to narrow down all the possibilities with them. So that's the thing we have now, that there are multiple solutions using PBN procedures in general, and we need to know which type of PBN approach procedure we need to each specific environment, and that's the work we can do. And you mentioned something really interesting from the cluster point of view. You are going to provide all the necessary stakeholders from the APP Aviation Partnership Project. We are going to make the necessary assessments from for each aviation authority, in particular the Indian one. We have been closely working with most of the people, and we have a representative from the GCA here who can speak about it. So we need to continue working together to see and to go back to the question, is this solution going to add value to your airdrome? Maybe yes, but we need to assess it.
Thanks a lot. Yes. There was one comment by Mr. Peter Kesterton. Maybe, sir, maybe you can come aboard and explain what your comment is, because I'm not fully getting it, to be honest. Okay. All right.
Okay, I see the question. I think a few minutes ago it was stated that if a runway has an instrument, okay. So if I understand what the question is, that you highlight a discrepancy between EASA and ICAO. What I understand from ICAO is that I'm aware about some ongoing discussions, but as far as I'm aware, it has not yet turned into a regulation yet. It's still within the flight ops panel, if I'm correct about this visual approach. It's an IFR approach down to a so-called visual point, from which you turn you cancel the IFR flight and you turn into a VFR, and then yes, you can land on a VFR airfield. Is it what you're referring to?
Yes. Gerard, the issue is more related to the aerodrome criteria than the instrument approach criteria. So many airfields cannot produce an instrument runway because of limitations on strip width. So it's actually a safer option for them to still maintain that that runway is a non-instrument runway, but of course the minima are much higher. But the safety is achieved by providing an instrument approach to that much higher minima. So it provides a more stable approach, it provides a more reliable approach, but not all states actually use that definition of a non-instrument runway. I mentioned the point that Yasa does not adopt that definition of a non-instrument runway. But I actually introduced this practical solution many years ago in the 80s in Edinburgh Airport, because we needed to construct floodlights for the cargo apron closer to the runway than would have been permitted if it remained an instrument runway. It was the secondary runway, so we made it a non-instrument runway, constructed the floodlights, increased the minima on the instrument approaches, and it solved all of the problems. The main runway was ILS Cat 3. So this sort of definition has been implemented, I think, worldwide for many years, particularly where the aerodromes cannot comply with instrument runway criteria. I hope that clarifies the point I was making at all.
Many thanks, Peter, and I fully concur. Of course, that fully agree that would bring significant safety benefit. I'm aware about such approaches, which are sometimes called as well cloud breaks. So the idea is to break through the clouds and then down to your IF instrumented guided down to a so-called visual point. From there, you need to have runway inside. If not, then of course you need to have again a missed approach IFR. Otherwise, it's pointless. Fully agree. I think, as far as I know, unfortunately, the regulation has not yet been updated, but discussions are ongoing, and I fully support these discussions.
Thank you.
Carlos, you raised your hand.
Yeah, it's just to mention that what Peter mentioned is true, but it also has to do with the definition of the conditions of an airport and the definitions of the air navigation procedure. So there are subtle differences, and it's true that when you find these differences, it's important to highlight them. And regarding, we need to be a little bit cautious when we talk about safety improvements in certain environments, because you can imagine that this is going to happen if the whole system works. And what I mean is, if you're going to introduce an IFR environment in a VFR aerodrome, for instance, you might find a lot of pilots that they are used to flight in a specific way, which means visual. And then if you have to train them, and if you need to equip their aircrafts with certain technology, but to perform this kind of IFR safer approaches, you need to be careful, because if you are changing the conditions of the system, you need to be sure that this is going to achieve a safer environment. So the statement is completely true, but you need to be careful about how to implement those conditions in certain or specific environments. That's the only thing I wanted to highlight.
I agree, Carlos, but I come across this mostly in the reverse scenario, where the instrument procedures exist, but the aerodrome is non-compliant. And what I've described is a solution to achieve compliance, both for the instrument procedure, which becomes a slightly higher minima, and for the aerodrome. And it's really a win-win situation. But you're absolutely correct in what you say. If you're introducing procedures to what otherwise is a completely visual non-instrument airfield, then there's a lot of training, there's charts, there's warnings in the AIP, a lot of issues to be discussed. And it's the whole principle of PBN, that the whole system complies with what is needed according to the minimum.
Yeah, and this is an old discussion. Imagine you need to transport yourself, or someone needs to be from one village to another, and she's using a bicycle because it's only 5 kilometers away. And then you could say, okay, if you use a motorcycle, it's going to be faster, and then if you use a car, it's going to be safer. But if they don't know how to operate it, if you don't have appropriate roads, maybe you are going to invest in something less safe. So that's the idea behind my reasoning. Sometimes when we think that we are introducing safety elements in the system, we need to be really, really careful. And that's why we need to perform safety assessments and to have a very good roadmap in each case, even if the safety assessments are really small. I mean, 2-3 pages, and you need to do this and that, and then when you're sure and you can guarantee that the conditions are met, then you can say that the new conditions are safer.
Absolutely agreed. Thank you.
Again, it relies upon the training, of course.
Yeah.
Sorry,
Mr. Thakur, you have raised your hand for a long time. Sorry to keep you waiting. Mr. Thakur, please.
Thank you so much, sir, giving for the opportunity. My question is to understand the capacity enhancement through the RNP. One example was given: the airport has, enhanced the capacity, double the having the declared capacity. So I would like to know more about the capacity enhancement through RNP, especially airspace management and runway throughput.
Maybe I can shed some light on that. Well, by implementing RNP procedures in around an airport in a TMA, you are going to ensure that the aircraft flying these procedures are going to fly a given pattern. That means that, well, basically compared to the rest of the traffic, it will be much easier for the controller to have a look on this aircraft, because by definition he knows what track they will follow first. And also the beauty of that is that it will also become much easier to manage the separations between the various aircraft following a given procedure. You know that they are not going to drift and to let's say to reach positions that would not be well known. Two aircraft following a given procedure, well, you just have to manage the separation, and that's a lot easier for a controller. If you multiply that scheme by any number of aircraft and procedures, well, you understand how big the benefit can become to alleviate the burden for the overall air traffic control in a given area, and let's say significantly increase the throughput to the airport.
How much the separation can be lowered? Can we achieve 3.5 nautical miles separation, arrival, departure, arrival, and arrival separations can be brought down?
Well, again, I don't believe. I mean, for like any of the, let's say, the explanations that we gave, there is no such thing as a absolutely generic answer. By definition, this should be a case-by-case approach. But and again, I'm no regulator. I'm no air traffic controller. So that still lies in the hand of these people. I would not go much below 0.5 nautical miles for sure. That starts to be even when in a controlled environment, that starts to be a bit tricky. But that doesn't mean that there is no room to let's say to greatly increase what separation is usually considered for other types of operation.
Got it. Thank you, Stephen.
Thanks a lot, Mr. Singh. You have raised your hand. Please ask your question.
Yes, sir. Thank you very much, sir, for giving me the opportunity. My question is, I'm just supporting the question, the subject which was raised by Mr. Peter. As he said, you should have approaches on the VFR runways. So within India, we have VFR runways which has NDB approach. So, but we are landing on those runways with 5,000 meters of visibility, taking off from them at 5,000 meters of visibility. So my concern is if we have RNP approaches on those runways, it would be much more safer than rather than having no approaches. And definitely, if we have those approaches, there could be a safety risk assessment which our internal flight operations can do, and we can lay down some regulation or some guidance for our pilots. So I would like you all to support this and create a guidance so that it goes to our regulator and they support this. Thank you very much.
Yes, Carlos, you raised your hand.
Yes, as we were discussing this, what I wanted to convey is the message that in theory, and of course I support your statement, it's going to be more safer if you introduce that in the system. That's the intention of this type of approaches. Just you mentioned also the needs, safety risk assessment and implementation procedure. And once you do that, of course, you're going to have safer environment in terms of approaching your runway. And from our point of view, we have the tools and the intention to, if it's necessary, to assess case by case and maybe grouping different airports and trying to, or aerodromes, and trying to see similarities and an action plan. So yeah, fully supported, and we take also the initiative.
Thank you very much.
Okay, so we are coming to an end. I think we have answered a lot of questions. A lot of questions on heliports and helicopter operations have been answered. So I would like to call it a day. I think it was a very good workshop. 2 days, very good insights, very technical, but also for us as a cluster, a chance to see where we are going. And I think we hit the nerve. And as I said, this is since PBN and also GRF, of course, it's a multi-stakeholder and multi-stakeholder engagement. We as a cluster can facilitate this in order to further cooperate with EASA, with governmental bodies, with regulatory authorities, and also with the industry, and bring it forward. So we have a lot of homework to do, and I'm very excited to move this forward. As I said, this is one of our working groups in the cluster. This is a safety working group. We are also forming working groups on sustainability and also on the topic maintenance, repair, and overhaul, which is coming up. So we'll be very busy in implementing and bringing up this topic in India, these topics in India. So before we conclude, and I say thank you to all of you, my communications team would like to take a group picture. So if you don't mind, all of you, please switch on your cameras so that my communications team can take a picture. Nidhi and Nancy, you are prepared?
Yes, we are, Atul.
Okay, very cool.
So we'll just wait for a few more people to join in case they're planning to.
Charles is making his hair. Okay, so we are ready when you are, Nidhi.
Sure. I think Mr. Rupesh Kumar Thakur, I think there's some issue with your screen or something with your camera. You're not really visible.
Yes,
there's a lot of disturbance. Okay, any which case, I think I'll just go ahead and take a screenshot. Okay, yeah. Sure. Thank you so much, everyone.
Thank you, Nidhi. And thanks to all of you. As I said, if you have any questions, please write to us. I think we'll be continuing with more technical discussions. I think on some other occasion. I think this will go forward, and I'm very excited to move this on. And as I said, we are there to move things on in India, and we as the EU-India Aviation Cluster, we can also support you in not only on business matters, but also on a policy level. So anything you have to address, please come up to me and my team, and we'll take it forward from there. Thank you very much for joining. It was a very, very interesting 2 days, and I'm looking forward to speak and hear from you in the future. Thank you very much.
Thank you.
Thank you, Atul.
Thank you, sir. Thank you very much.